All right, 6C, we're going to talk about geometric probabilities, okay? So binomial and geometric experiments have some things in common. They're very similar with one key difference. So the things that they have in common is number two and number three. So only two possible outcomes, success or failure. That's just like what we did with binomials, and then P is the probability of success and Q is the probability of failure. All right. Three, the trials are independent. Okay, so P and Q have to be the same for each trial. That's the same as our binomial. The part that is different is that in a geometric experiment, the trials are repeated until a success is achieved. Okay, whereas in the binomial, we had a fixed number of trials. So a situation would be binomial if I said I was going to flip a coin 20 times and count how many times it lands on tails. A situation would be geometric if I said I'm going to flip the coin until it lands on tails. And I'm just going to keep track of how many times that takes. Okay, so that is the difference between a binomial and a geometric. Okay, geometric distribution has its own formulas. For mean, the mean is equal to 1 over p. Okay, and just like for binomial, we might say mean, we might say expected value, we might say how many do you expect. All right, it is the expected number of trials it would take to get success. All right, and then the standard deviation is the square root of 1 minus p over p. Okay, so 70% of stat students turn their practice problems in on time. If you randomly select students, let x equal the number of students you must ask to find one who has turned in their practice on time. Okay, is this a geometric distribution? All right, the answer is yes, because we have only two outcomes, success or failure. Each trial is independent. One person doing their homework or their practice problems has no effect on whether or not the next person does. And we're going to ask until we find a person. So that is our stop when we reach success. So this is a geometric distribution. The value of P would be 0.7 because 70% turn their practice problems in on time. So if we want the mean and standard deviation, we need a calculator. I'm going to use Desmos. So the mean is 1 over P, so 1 divided by 0.7. All right, so that gives me 1.42. So I would expect to ask somewhere between 1 and 2 people before I get somebody who says, yes, they have turned it in on time. And my standard deviation is going to be the square root. You can use the keyboard or you can type square root, SQRT, to get that root. And it is the square root of 1 minus p, so 1 minus 0.7. And then we're going to divide that whole thing by p. So the standard deviation is 0.782. All right. Okay, then probabilities. Okay, just like we did with binomial, we're going to use geometric. Okay, so we're going to use Desmos again. We get rid of these. I'm going to go to my keyboard. All right, go to functions again. Still scrolling down to that probability. So here's our binomial that we were doing. Now we're going to do geometric, so geodist. Okay, it only needs, remember Desmos will always tell you what they want. They want the success probability. Okay, so P in this situation is 0.7. All right, and then we can click cumulative probability to get all of our options. So let's look at some examples. All right. Find the probability, you have to ask exactly 12 students. So just like we did with binomial, I can go to the number 12 and click on the circle and get the probability, or I can do enter and do 12 exactly. That number is basically 0, as you can see. Okay. All right, so our next question, find the probability you ask less than 3 students. Okay, so less than would be left. All right, and just like with the binomial, it's less than or equal to. So I'm going to put 2 because I don't want to include 3 in this answer. So that probability is 0.91. And then number three, find the probability you ask at least four students. Okay, so at least four means four or more. So that means I need to change this to right. And I want at least four. So my probability there is 0.027. Okay, very similar to what we did with binomial probabilities. The biggest thing is recognizing, do we have a fixed number of trials, or are we going to keep going until we succeed? That is the difference between binomial and geometric.